Hello, my name is Bahram. Today I'm presenting the paper of Understanding Database Reconstruction Attack on Public Data. So, to explain what the problem is, this article has used the US Census data publication. As census involves collecting large amounts of private data under the promise of confidentiality, traditionally statistics are published only at a high level of aggregation. The published statistical tables are vulnerable to DRA's database reconstruction attack, in which the underlying microdata is recovered merely by finding a set of microdata that is consistent with the published statistical tabulation. A DRA can be performed by using the tables to create a set of mathematical constraints and then solving the resulting set of simulation equations. This is related to what we studied in our lecture reconstructed attack example of census data, which includes fields such as age, sex, race, and many more. This article shows how such an attack can be addressed by adding noise to the published tabulations so that the reconstruction no longer results in the original data. The goal of the census is to count every person once and only once and in the correct place. The results are used to fulfill the constitutional requirement to apportion the seats in the U.S. House of Representatives among the states according to their respective numbers. Many statistics can accidentally provide information in a way that it can be attributed to a particular entity. For example, if a statistical agency accurately reports that there are two persons living on a block and that the average age of the block residents is 35, that would constitute an improper disclosure of personal information because one of the residents could look up the data and subtract their contribution and infer the age of the other person. So, computer science started exploring the issue of statistical privacy in the 1970s, similar to what we learned in our lecture. The goal was to build a system that would allow users to make queries that would produce summary statistics without revealing information about individual records. Three approaches emerged: auditing database queries, so that users would be prevented from issuing queries that zeroed in on data from specific individuals, adding noise to data stored within the database, and adding noise to a query to results. In 2003, Eric Dinor and Kobi Nassim showed that those two computer scientists showed that it isn't even necessary for an attacker to construct queries on a database carefully to reveal its underlying confidential data. Adding noise to either the database or to the results of the queries decreases the accuracy of the reconstruction. But it also decreases the accuracy of the queries. The challenge is to add sufficient noise in such a way that each individual privacy is protected, but not so much noise that the utility of the database is ruined. Later on in 2006, these two computer scientists and two others published a paper called Calibrating Noise to Sensitive in Private data analysis, which introduced the concept of differential privacy. They provided a mathematical definition of the privacy loss that persons suffer as a result of a data publication, and they proposed a mechanism of determining how much noise needs to be added for any given level of privacy protection. In 2020, census is expected to count roughly 330 million people living under roughly blocks, with some inhabited blocks having as few as a single person and other blocks having thousands of people. This article presents a database reconstruction of a much smaller population. A hypothetical block containing 7 people distributed over 2 households. Even a relatively small number of constraints results in an exact solution for the block's inhabitants. Differential privacy can protect the published data by creating uncertainty. Similar to the example of reconstruction attack we saw in the lecture, the author of this article has considered the census of a fictional geography frame. To simplify the example, this fictional world has only 2 races: black and African American or whites, and 2 sexes, female and male. The statistic column is for identification purposes only. Notice that a substantial amount of information in Table 1 has been suppressed, making with D, a letter D. In this case, the statistical agency's disclosure avoidance rules prohibit it from publishing statistics based on 1 or 2 people. This suppression rule is sometimes called the rule of 3 because cells in the reported source from fewer than 3 people are suppressed. Alright, the database can be reconstructed by treating the attributes of the persons living on the block as a collection of variables. Same as the example we saw in the lecture, a statistic 2b states that 3 males live in the geography. The oldest possible age of any human being was considered 105 years. There are only a finite number of possible age combinations. After doing the math, there are only 30 combinations that satisfy the constraint of having a median of 30 and a mean of 44. There are 3 approaches for defending against a database reconstruction attack. The first is to publish less statistical data. This is the approach taken by legacy disclosure avoidance techniques, self-suppression, top coding, and generalization. The second and third approaches involve adding noise or randomness. Noise can be added to the statistical data being tabulated or to the results after tabulation. Each approach is considered here. Although it might seem that publishing less statistical data is a reasonable defense against DRA, this choice may severely limit the number of tabulations that can be published. A related problem is that with even a moderately small population, it may be computationally infeasible to determine when the published statistics still identify a sizable fraction of individuals in a population. So this approach is called input noise injection. For example, each respondent's age might be randomly altered by a small amount. Input noise injection doesn't prevent finding a set of microdata that is consistent with the published statistics, what we call database reconstruction, but it limits the value of the reconstructed microdata since what is reconstructed is the microdata after the noise has been added. This approach is called output noise. the third approach. Whereas input noise injection applies noise to the microdata directly, output noise injection applies output to the statistical publications. Output noise injection complicates database reconstruction by eliminating naive approaches. And finally, the conclusion, with the dramatic improvement in both computer speeds and the efficiency of SAT, that's the application of SAT and other natural language processors, hard solvers in the last decade, GRAs on statistical databases are no longer just a theoretical danger. The vast quantity of data products published by statistical agencies each year may give a determined attacker more than enough information to reconstruct some or all of the target database and breach the privacy of millions of people. Faced with the threat of database reconstruction, statistical agencies have two choices. They can either publish dramatically less information or use some kind of noise injection. Agencies can use differential privacy to determine the minimum amount of noise necessary to add to their data. So this was my presentation for the course CS 590 privacy. Thank you so much for your time.